Hello and welcome to this new video. In the previous video, we prepared the UI so that we can display the dedicated server sessions. In this video, I will show you how to create and search for dedicated server sessions. Managing dedicated sessions is easier than player-hosted sessions. Everything will be in the game mode of a playable level. This is the best place to manage dedicated servers because the game mode runs on the server side only. It should be noted that a dedicated session does not automatically provide a voice chat service like lobby sessions. We will see later how to create and manage voice chat for players on a dedicated server. Also note that you do not have to build your project from the Unreal Engine source code to be able to create and test a dedicated server. This will be done when you go into production. You will see in this video how to start a dedicated server from the command line as we did for the lobby players. Before I start, I just want to adjust the UI for a clearer display. Follow me if you are interested. Note that in a real game, you should not allow players to see the list of dedicated servers. Your game must implement a matchmaking code that searches for the dedicated server for a player according to criteria that you can define. For example, according to the player's rank and achievements. But the UI there is for the need of the tutorial, as well as for you as a game developer. Make sure you choose the dedicated type when searching for dedicated sessions. I forgot to do this in the previous video. Indeed, we don't need the UI refresh event, because that was for the lobby sessions in order to play on the visibility of the buttons which manage the lobby session. To start the work on dedicated servers, I will implement the logic in the game mode of World 2. We can always implement it in the game mode of World 1. But I will not do it to avoid confusion with two different implementations, so a game mode that manages players' hosted match and at the same time it can manage the session of a dedicated server. Like this, I show you the implementation in a game mode from scratch. You will therefore be able to mix the two implementations in a single game mode, because in a real game, the game mode is supposed to be playable on a dedicated server and also for a player-hosted match if ever your game must provide both possibilities to the players. So go to the World 2 folder and add a new game mode. Make sure it is a child of the master game mode. Now add a new player controller of type master player controller. Open World 2 game mode and override the Get Master Game Mode reference function. Now change the default player controller to be the World 2 player controller. Then change the default pawn class to be your own character. In the Begin Play event, I don't need to call the parent event, because in the case of a dedicated server session, there are no notifications that are triggered on the game instance side when the session is updated. It was just for lobby sessions. Now open the player controller of World 2. Then, override the Get Master Player Controller reference function. What I want to do in this player controller is the same thing of the lobby player controller, especially the implementation of the controller readiness, because in the case of a dedicated server, the event on post login is executed when a client connects to the server. So it is useful to specify to the server at what moment it can interact with the connected player controller. We also want the server to be able to have the player cards. This is useful if you want to create teams. You can therefore identify them on the server side according to the player cards. Copy the Setup UI function. We will change the widget to display in World 2 later. Do the same for the Check for Player Card Readiness function. This is the function that notifies us when the player controller is ready. Now copy the whole implementation. Create the timer variable. Change the input mode to Game and UI. Now we need to create the widget for World 2. It will be a simple widget that contains a Leave Match button. So you can duplicate the World 1 widget and then change its name. Remove the implementation of the button when it is clicked. It will be a different implementation in case of dedicated server match. We will see that later. Go back to the World 2 player controller and assign the widget to the node. Now open Level World 2 in the editor and then change its default game mode to be the game mode of World 2. I'm going to open the game mode lobby to get inspired and also to show you the difference when working on a dedicated server. As I have already announced, when working on dedicated sessions, we do not need to keep track of session updates from the game instance. Use the Unreal Engine node is dedicated server, which returns true if the game mode runs on a dedicated server and false otherwise, so a listen server, in other words player-hosted match. This is the node that you must use in your game mode to identify what must be executed in case of dedicated server and what must be executed in case of listen server. For the event on post login, it will be the same implementation of the lobby game mode because we want to wait for the player controller readiness and thus update the player cards on the server side. We also want to add each connected player controller to the list of controllers and thus increment the number of players. So copy the implementation, then paste it into the game mode of World 2. Remove the On Player Controller Ready function. We will implement it later. Please note that in the case of a dedicated server, the on-post login event and the on-post logout are executed only for clients, therefore players. This is the opposite of the case of lobby game mode, which represents both a server and a client at the same time. For the on-post logout event, we just want to update the number of players, the list of controllers and the player cards. We don't care about the members settings because in the case of a dedicated session, it has no effect to add the players as members of the session. So copy the implementation, then follow me to remove what we don't need. I now want to add a function that is used to update the player cards on the server side when a player controller is connected and ready. This function therefore takes as a parameter an input of type controller. Call the function when a player controller is ready. Then follow me to update the player cards variable. To get the player card of the connected player, we must first call the master controller interface function, getPlayerCard. Now this is the important part. In case of dedicated server, dedicated session creation will be when dedicated server is started and so begin play is executed. Always remember that in case of dedicated server, it is server that manages session and not players. You can create session by using interface event create session, but try to avoid implementing features through interfaces in case of dedicated server. Because interface allows other objects to communicate with game mode, and so we don't want client to ask server to create session by calling interface function. The most secure method is therefore to create a macro in the game mode which is used to create the session. It will also be the same process to follow for all other interactions with the session, such as updating the session and managing its lifecycle. In the macro created, call the easy OSS task, create OSS session. Then connect the execution pin to the input. For the other inputs of the task, we must not connect them to the macro input, because this macro is called only in this game mode, and therefore we will give values to each input directly. Make a map for the filters to give to the session. Remember that these filters will be used by the game client to find the session. So open the DS Sessions widget to define what to give as a filter when looking for a dedicated session. The first key value pairs will therefore be the session type which has the value dedicated. We must add a second key value pairs representing the game mode. This is useful when the client wants to play a specific map, so it filters the sessions of this map only. We want to add a key value pairs representing the number of players in the session, as we did for the lobby session. Please note, in the case of a dedicated server, this key will have a value of 0 upon creation. Remember that the dedicated server is not a player, unlike the case of a lobby session where a server is also a player. Because it is a dedicated server, we must also pass its host and port in the filters. So the client will be able to find the URL when joining the dedicated session. Note that in the case of the lobby session, we did not add this information in the filters, because when joining the session of a lobby, the task join OSS session returns us the connect info of peer-to-peer socket. On the other hand, in the case of a dedicated session, the task join OSS session returns a connect info containing the correct host IP but always the port 7777. Because the EOS OSS can know the IP of the host of a dedicated server, but it does not know the port on which this server runs. We now want to create the command line that is used to start our dedicated server of World 2. First, go to your project settings, then to Online Subsystem EOS. We will need the name of the artifact of the trusted server. Remember that the trusted server artifact uses a policy that allows it to create dedicated sessions, unlike the artifact of the game client which does not have the right to do so. Duplicate the bat file of player 1 and name it ds_world2, then open it. The first thing to change is the name of the map. In the case of a dedicated server, we must pass the name of its map, so in our case it is World 2. Then replace the game with server, because it is a server. For the Epic app, we must pass the name of the artifact of the trusted server. Then we must remove the other authentication parameters, because a trusted server does not require an authenticated user. Return to the game mode of World 2, then call the macro to create the session. Open the macro to give the other parameters to the task. I want to set a max public connection to 20. You can set the value that suits you, depending on your game. For the anti-cheat protected, I leave it unchecked. We'll see that later in the anti-cheat section. Then check the box should advertise to create a public session. For the other presence and join parameters, I also leave it unchecked. Make sure to set the type to dedicated. I check the Use Stats box, because I want to keep track of user stats. We will see that in the Stats and Achievements section. Go to your dev portal, then in the product name, then in the game services. Dedicated sessions are searchable in the matchmaking section. Search for the session using the filters that we have defined. Back in your project, we just want to fix the display of content in the DS Session Item widget, so we want to use the right keys to display the URL of the dedicated server session. Find the values of the host and port keys and then form a string that represents the URL. Now run the ds_world2 script. You will see that nothing happened. This is normal, because the dedicated server was started but in the background. If you open your task manager, you should see an instance of Unreal Editor representing the started dedicated server. If you go back to the dev portal, then you should see that there is a new session that was created by the dedicated server. So the begin play was executed, and therefore the creation macro created the session. Search for the session using the filters that we defined during creation, then click on the session found. You should see all the configurations that we defined for this session. We can clearly see that EOS was able to know the public IP of the server, but there is no information concerning the port of this server. Unlike lobby sessions, the dedicated server has 0 players once the session is created. Note, when a dedicated server is started, you cannot save your blueprint in case of modification. You must first end the task from your task manager. Background startup is useful when you go into production. But in our case, we are in the dev phase. So it's annoying to go to the task manager every time to kill the processes. Moreover, when we develop our dedicated server, we need to have its log to understand its behavior. So go to the ds_world2 script and then add the log flag. Launch the script. You will see the initialization of the dedicated server from the logs, as well as the easy OSS logs which inform you of the callback status of the tasks. You can also use your blueprint to print strings to log. In this case, if you close the logs window, the dedicated server process will be killed automatically. Back to World 2 game mode, we just want to add the values of the host and port keys to the session filters when creating. To get the host IP of the dedicated server, you can hard-code it if you know your remote VM IP on which your server must run. Also, you can use the local host in case of dev to test the join process later on the same machine. Anyway, Easy OSS provides you the node, get public external IP, which returns you the external IP address of your server automatically. This node requests an AWS endpoint to find the IP. The advantage of this node is that it automatically detects the host IP regardless of the VM on which your dedicated server is running. Also, it works in case of dev, because the returned IP is accessible from the local machine. Anyway, it's not a problem to provide the host IP to the clients via filters, because the join node can return it to the clients. So the real problem is to provide the dedicated server port to the clients. So it's important to pass it in the filters. To automatically get the port of the dedicated server, Easy OSS provides you with the node getRunningGame port. Now connect the task output to the macro output node. There is no need to connect the OSS error structure, because in the case of a dedicated server, there is no UI on which you can display an error message. When you look at the logs, Easy OSS displays the errors without needing to print them to the logs. I want to talk to you about an important topic now, In fact, it is useless to leave the server running if ever the creation of the session has failed, because it will be inaccessible and also it consumes the resources of your VM. So in this case we must kill it automatically. Easy OSS provides you with a node that does the job. But in a real game, it is useful to give the dedicated server the opportunity to try to create the session several times in case of creation failure before deciding to kill it. What I want to do therefore, is to implement a logic of attempt to create the session in case of failure. So create a custom event, and name it Create Dedicated Server Session, then move the creation macro from the Begin Play event. If the creation is completed successfully, we will call the event dispatcher on session created. We must first promote the session to a variable to keep a reference to it. If the creation is failed, we must call an event dispatcher which informs us that the task has failed. So go to the master game mode and add this event dispatcher. Return to World 2 game mode, then call this event if session creation fails. We must now assign these two events in the Begin Play event before calling the Create Dedicated Server Session event. What we are interested in now is to call a retry script when the event dispatcher on creation session failed is triggered. So I want to add a custom event that will be called when the delegate is triggered and which is used to retry the creation of the session. The implementation therefore consists of trying to call the creation event. I want to give in this example a number of attempts equal to 10. so this event can be called a maximum of 10 times before killing the server. So create a variable of type integer and name it number session creation attempts. Its default value must be 0. If the value of this variable is less than 10, we will call the creation event. If it is greater than 10, we will kill the dedicated server. To kill the dedicated server, call the easy OSS node, request engine exit. We will set a delay of 2 seconds between each creation attempt. Like that, I give the dedicated server a period to wait for the resolution of a network problem if it exists. At each creation attempt, the variable is increment, otherwise the script will enter an infinite loop. If the creation is complete, then we must reset the variable to 0. This is useful if you want to manage several dedicated sessions in game mode. Now we need to call the event we created when the failure delegate is triggered. To be able to test this implementation, we must simulate a creation error. You can, for example, launch the dedicated server when your PC is not connected to the internet. I simulate it with a simpler example. You just have to replace the artifact of the trusted server with the artifact of the game client to produce a creation error because a game client is not authorized to create dedicated sessions. You can add the port flag to override the default port used by Unreal Engine. Be careful when launching several server instances. The port you specify in the script will be automatically incremented by Unreal Engine, because the port is used by another server instance. Now run the script. Once the server is initialized, it will try to create the session, but the creation will fail, so it will retry every 2 seconds until reaching the max of attempts. Finally, the request engine exit will be executed. And there you have it. If the server fails to create the session during these attempts, it is therefore automatically killed by the node request engine exit. Don't forget to put the correct artifact name back at the end of the test. Now run the script again. The session should be created successfully, and thus the retry script will not be triggered. Also open a game client to verify that the client can find the dedicated session created. And voila! The client can find the dedicated server sessions as well as their information such as the URL used to connect to the server. Note that when you close a dedicated server, the session will be automatically destroyed on the EOS backend, but it can sometimes take several minutes. That's all for this video. See you in the next one.